Hello friends, Mr. Burrell here. Sorry my camera's being weird. It's at a different angle. We're working with what we got here. But we are in Unit 8. We're talking about logarithms. We're talking about exponential functions. We talked a little bit in the last video about what a logarithm is, how exponential and logarithm functions are inverses of each other. So today we're going to start talking about transformations of exponential and logarithm functions. These are things that you've kind of already started to notice. But we're going to talk about how to draw these transformed graphs. This should say Unit 8.4. I apologize. But by the end of this class, I hope that you're able to graph transformations of exponential functions and write an equation of an exponential function given the certain transformations. And I hope that you're able to do the same thing with logarithms. Graph them and write the equation given some transformations. So that's the goal by the end of this video. So right here we have the graph of f of x, or y, equals 2 to the x. Crosses the y-axis at 0, 1, and has a horizontal asymptote, at the x-axis, or at y equals 0. So the y-intercept is 0, 1. The domain is negative infinity to positive infinity. Always, for any exponential function, the domain is from negative infinity to positive infinity, and the range in this case, since the horizontal asymptote here is at y equals 0, the range is from 0 to positive infinity. Now, let's look at a transformed version of that parent function. So right here I have y equals 2 to the x minus 3 power minus 5. So first of all, the traditional parent exponential function would cross the y-axis here. So I know this point for sure of the parent function. Right here, if you remember, inside the exponent affects my left to right movement. Outside, so I should box that in, outside the exponent affects my up and down movement. So from this point, I'm going to move to the right 3, because remember I do the opposite of what's inside the exponent. So I move right 3. And down 1, 2, 3, 4, 5. So this is a new point of this graph. Also, originally I had a horizontal asymptote right here. But remember, I shifted this whole graph down 5 units. So that horizontal asymptote is also going to move down 5 units. So this right here would be my new horizontal asymptote. And this right here would be approximately my new graph. So if I'm writing down the transformation, I'm going to say right 3, down 5. Now my domain is still negative infinity to positive infinity. For every exponential function, the domain is negative infinity to positive infinity. All the possible x values is every single thing in the entire real number spectrum. And then the range now is going to change, because now I shifted my horizontal asymptote down to negative 5, so my range is from negative 5 to infinity. So that's how this transformed function affects some of these different characteristics, these different qualities of exponential functions that we've talked about. So again, inside this exponent affects the left to right, outside of the exponent affects the up and down. Okay. What about this one? This is the graph of y equals log of x, or f of x equals log of x. Remember that a logarithm function is the inverse of an exponential function. So it's just flipped over that y equals x line. So now instead of crossing here, it's going to cross at the point 1, 0. Now the domain and the range are going to flip. The range of an exponent or of a logarithmic function is always negative infinity to positive infinity. And the domain of this parent logarithm function, because I have a vertical asymptote as the y-axis, the domain is going to be from 0 to infinity. Those are some of the characteristics we've already discussed of a logarithmic function, and this is what it looks like. Through this point, we're going to focus on that here in a minute. So, when I'm talking about a transformation of a logarithmic function, right here, again, I'm looking inside the parentheses for my left to right movement and outside for my up and down movement. So right now, right off the bat, I can tell that I'm going to move right 2 units and down 5 units. See that? So right here is where my parent logarithm function will always cross at 1, 0. So from there, I'm going to go right 2 and down 1, 2, 3, 4, 5, right here. So this is a new point on my graph that I'm going to cross. Notice this was my old vertical asymptote right here at y equals 0, but I've shifted my whole graph to the right. This camera is weird. To the right 2 units. So now instead of this being my vertical asymptote, my vertical asymptote is going to be at x equals 2, right here. So this right here is approximately what my graph is going to look like. Notice now that my range is still negative infinity to positive infinity. Because it's everything, I'm still touching everything up here from top to bottom. Then my domain now, since I shifted to the right 2 units, is going to be from 2 to infinity. From right here at 2 all the way to infinity. So that's how I describe a transformed logarithmic function. So if you have my guided notes, you'll notice this on page 8. We skipped over the rest of these, but a transformation inside the exponent in an exponential function, or inside the parentheses in a log function, inside that affects my left and right movement, and I go the opposite direction of what the sign says. So like on that previous slide, I had like x minus 2 in parentheses. That made it shift to the right 2. So inside those parentheses or inside that exponent, I shift left and right, opposite direction of what the sign says. Good? Now, a transformation outside of the exponent or outside the parentheses, that's number on the outside, is going to affect my up and down movement, and it's going to go the same direction as the sign. So I had like log of x minus 2 minus 5, that number on the outside of the parentheses, that minus 5 affects my up and down movement. So it'll move down 5 units because it's the same direction as the sign. So that's how I take care of these transformations. Now, if I give you some transformations, now we're going to talk about how I would write those functions. So remember that an exponential function is of this form. Y equals a to the x minus h plus k. I just put those letters in because they can be anything. Where, again, here in the box, inside the exponent, that's going to affect my left to right movement. Outside the exponent is going to affect my up and down. Inside the parentheses is going to affect my left to right movement. Outside of the parentheses is going to affect my up and down. So, if I have this transformation, left 2, up 3, with a base of 6. So this a here is the base of my exponent function. Since I'm moving left 2, that's going to be this number up here in the exponent, because that affects my left to right movement. And it's going to be the opposite sign that's given. So if I'm going left 2, this is going to be x plus 2. And then this number on the outside is going to affect my vertical shift, my vertical changes. So this plus k, if I'm going up 3, I'm going to have a plus 3 out here. So that right there would be my transformed function. If I go down here, again, if I have a movement right 4, a range from 1 to infinity, and a base of 4, I'm going to have 4 to the x minus 4 power, because remember, up in that exponent is affected by my left to right movement. And on the outside here, I'm going to have a plus 1, because if I shift to the right 1, my range of my exponential function is going to be from 1 to infinity. So that's my transformed exponential function. Let's try a logarithm. So again, my log function is going to look something like log of x with something in parentheses and then something outside the parentheses. This transformation is left 4, down 2. Remember, my left to right movement is taken care of inside the parentheses. So if I'm moving left 4, this is going to be a plus 4 because it's opposite. And then remember, on the outside of the parentheses, that's what affects my up and down movement. So this on the outside is going to be minus 2. So my function would be y equals log of x plus 4, close parentheses, minus 2. Okay? So this last one, again, it's going to look something like this. Log of x with something in the parentheses and then something outside the parentheses. Right off the bat, this function says it's being shifted up 5. Outside of the parentheses affects my up and down movement. So this is going to be a plus 5. Right here, I'm given that my domain is from 1 to infinity, from a positive 1 to infinity. So that means my logarithm function has been shifted to the right 1 unit. So remember, inside the parentheses affects my left to right movement, and it's opposite of what is given. So if I'm moving to the right 1, I'm going to have an x minus 1 in here. Notice here it gives me what the range of this function. I don't even have to use that to write my function because the range of a logarithmic function is always negative infinity to positive infinity. So my function is y equals the log of x minus 1 plus 5. So that's what I've got for you. Hopefully at the end of this video you're now able to graph transformations of exponent and log functions and write the equation of exponent and log functions given some transformations. If you need to rewind and review some of the problems we did in this video, please feel free to do so. But I hope that was helpful, and I hope that you enjoyed it as much as I did.